morning, welcome back to the lecture on 3D measurements. Now we will take you to the machining science laboratory in mechanical engineering department, and we will see what is coordinate measuring machine. So this is coordinate measuring machine in our machining science lab, spectra coordinate measuring machine. And this is vertical bar. This is a bridge type coordinate measuring machine. We have 18 pneumatic bearings. So one bearing is on this side, okay, one on this column, 11 in this column. So we are removing the bellow from here. When we remove the bellow, we can see there is a bearing inside. So there are 11 bearings on this side, 1 on this side and 6 on this side. 11 plus 1 plus 6 is 18. So this is pneumatic bearing, okay, that helps to move the columns and various other movements. Okay. So bellow helps us, this bellow helps us to save it from the dust, to keep it secure from dust. So this can move, so you know this can move freely here. So it can compress and produce spring motion due to air blow. Like there is air flow between the two surfaces, it can compress and produce the spring motion, so that it can move from one side to the other side. So there are 6 bearings on this side. Okay. So this side to side movement is possible, and microfilm flows due to complete dry air. So this is the controller. This is the controller that is used to switch on and off the compressor. Okay. So this is the controller knob. So we have Renishaw servo power amplifier. Okay, Renishaw is the company, it is the make. So this is the tube pipe from which compressed air is coming from the compressor. So this is the Kaiser compressor. It is refrigeration type air compressor. It is 100% moisture free, that is not going to harm the machine. So the compressor that we have to use here has to be moisture free. You know, we are trying to save the machine using these bellows from the dust and other impurities, so that the dust particles just come in between the moving components and does not act as abrasive. It may deteriorate the machine in the long run. So to save that, and also to save the machine from being corroded, this kind of refrigeration air compressor and moisture free air compressor is used. This is the control valve. So the front view of the compressor looks like this. It is Kaiser air compressor. So this is our coordinate measuring machine. As I said, this is used to measure the parameter of 3D objects. The 3D objects may be complex geometry or maybe some specimen. So we can measure with the help of the CMM. So it has 3 axes, okay, so X, Y and Z. This is a 3D object that we will measure using this coordinate measuring machine. Okay, we will try to measure the features of this component. So you can see there are number of circles here. Okay, there is center circle here, center cylinder here. Okay, we have circles here. Okay, and then we have 6 cylinders around this center cylinder. Okay, I will just measure this full cylinder. Okay, then I will this 6, 1, 2, 3, 4, 5 and 6. I will measure, try to locate these 6 circles, not the cylinders. So also we have a cone in the other direction. We have this cone here. We have this surface at an angle. This surface, okay, this plane and this plane is at 90 degree. So let me first talk about the axis. Okay, there are 3 axes. When I switch on, you can see that the indicator is on. So this is our y axis. When I move in this direction, this is our y axis. Okay, this is our z axis. Okay, this is z axis. We have actually, this is LVDT. This is LVDT. We have 3 LVDTs. Each axis has an LVDT. These LVDT is for this LVDT is for z axis. So inside the column above we have for y axis. Okay, here we have for y axis, and also we have for x axis as well here. Okay, this is the probe. This is the probe, we can rotate it to 180 degree. Okay, this is 180 degree. Okay, it can rotate it to, and this can be rotated to 90 degrees, 0 to 90. Okay, so we can index it, index to 90 degree here. So index the point to 180 degree. So this is the one position in the stylus. So this is stylus. If you see the tip of the stylus, this is sapphire ball. This is of sapphire material, then the diameter is 2 mm. So this rotation, I'll let you know, this rotation is called as A. This rotation is called as A, and this rotation is called as B. Okay. So A can rotate up to 90 degree, B can rotate up to 180 degree. Okay, 90 degree on this direction, this can rotate up to B can rotate up to 180 degree. Or we will try to explain it using the help of the software. The name of the software is Tangram software. So how to start here? We first click on the UCC server. UCC, as I said, UCC is Universal CMM Controller. So we have Renisar UCC controller, which is designed to link the hardware of a coordinate measuring machine to the coordinate measuring machine host computer. So this is the host computer, we have the hardware machine. So read heads, probes, probe head controllers, limit switches, emergency stop, analog signals to servo amplifiers, joystick unit, all these things are the components of the coordinate measuring machine. The purpose of UCC is to permit the control of CMM from the front end software. The controller provides the control signals to CMM probe system necessary to give the required response. For example, to position the target to the given parameters. So there are certain purposes that this UCC controller accomplish. For instance, data transfer and control. So then communication with the controller. Then specialized controller features also, they are like CMM measuring accuracy enhancement, then measurement coordinate systems, we can use different coordinate system, digitizing and scanning abilities are also there. Then data filtering can also happen using this controller here only, because we can create the file in IGS format. So what is IGS format? We will produce, IGS format would produce a lot of codes. Okay, a lot of codes can be produced. One who has some information of the codes can also use those that format when we produce a shape. One thing is just have a geometrical shape. Another thing is we can have the data in Excel format. We can have the data in IGS format. So the graphic user interface one can try to learn in depth also. So these things are possible. Interfacing to the other components is also possible through this UCC controller. So next I am trying to generate a platform to measure the features of the object. So we click on the machine here, okay, we right click here and click set. When we click set here, so then we can click yes. Okay, the machine is going to home position now. Is the reference tool is when we click, machine is going to the home position. So I will come to machine, you can see the machine is going to home position by itself. So going to home position serve multiple purposes. One thing is it is made sure that each and every component is working properly. Second thing is that machine is now free to take it to the desired position wherever the operator would like to take it to. Okay. It will first, it went to Z home position and it went to Y home position and it went to X home position. Okay. I can repeat it again. So first is Z home position, then Y home position. This is Y and X are moving simultaneously, Y and X home position. So it has now went to the home position. Now machine is homed, I can say. Okay, there, now machine is home. Now X is moved. Now machine is homed. Okay. Other components, we have this software and we have this granite surface plate or surface table here. This is 0 grade surface plate. As I said, the accuracy is quite high and the thermal expansion is 0. Okay. So the size of the machine is 500. Okay. This distance, this distance is 500. Okay. 564. This distance is 600. from here to here, this distance is 600 and the height is 400. So, that is why it is known as 5, 6, 4. So, this is spectra 5, 6, 4. So, the next component is joystick. Okay. So, when we rotate this joystick clockwise, it moves z direction downwards. When I rotate it anti-clockwise, it moves the z upwards. Okay. So, this is left x motion, x axis motion. Okay. And similarly, I can have right x axis motion, y axis again back side, okay, then forward side. So, this is simple joystick, okay, the operator can control. The only y and x axis are very similar to the movements there. So, only the thing is that rotation of this knob anti-clockwise and clockwise makes it to move, makes the z axis, this is fast forward. So, this is joystick x, y and z, okay, x, y and z. So, this is engagement of sensitive mode, engage sensitive mode if it is required. So, we would not work on this. The software here is tangram, we have the indicator here, indicator would blink and when this will touch, and also a beep voice would come. So, we are actually trying to put the voice over the recorded video. So, the actual laboratory conditions are quite noisy. We will also try to show you the actual laboratory conditions when we will start the measurement and like to hear the voice and the noise there as well. Now, we open the new project, we open the new project, okay, then screen opens. So, first we take the reference system, then we take 3 points, top plane and 3 points are taken from the other plane and cylindrical point from a region, then we select the plane and move the joystick. So, this is our workpiece, the features of which we are going to measure. So, we will take 3 points on this plane, 3 points on this plane. Okay. So, this is our cylinder, this is cylinder. What is this plane? This is z y plane, this is z x plane. What is this top plane? This is x y plane. Okay. So, this we have selected plane 1. It will try to record the points, at least 3 points are required to define a plane. So, we will record the points using joystick. We are trying to move the probe close to the component when they will touch the tip of the probe, that is the fire material. Okay. We are doing it again, we have selected the plane from here selected. So, before moving all the components, we have point, line, plane, circle, arc, cylinder 8 points are cone 8 points, sphere we need multiple points for this sphere, slot, square slots, ellipse, curve, surface, torus. They are, you know, there are multiple objects here in this software, and this is just the general or the structured surfaces. Free form surfaces are when we just measure the free forms. Then we have distance, angle, point, these are the construction measures, okay, what we need to measure, the measure the plane, they measure the line. So, this is general measure, okay, that was construction. Then we have various other tools like 3-dimensional other forms, etc. So, we are just touching it 2, 1, 2 and 3. Okay. 3 points are now recorded in our software. So, it has shown this plane here, this plane 1 is now defined. We can name the plane as well, we can name it xy plane, we can mark it whatever name we would like to give, we can name the plane as well, but it has just marked it plane 1 because we did not change the name, the default name was plane 1. Now, we will select the plane again, it is select plane 2. Now, I am selecting the YZ plane 1, 2 and 3. You can see the light blinking. When the light is blinking, that is the probe has touched 1, 2, 3. Okay. 3 points are recorded and the second plane which is perpendicular to this one is generated, plane 1 and plane 2. Now, I will measure the cylinder. So, 3 points for plane was selected, for cylinder we need 8 points. Okay. 8 points, 4 points in one plane, 4 other points in the second plane. 4 points in one plane means 4 points will give me the location of the cylinder of that will mark one circle, another 4 points at a little depth than the initial plane would give the second circle. These two circles would help us to generate a cylinder. The cone can also be generated similarly. So, this is 1, 2, 3 and 4. Okay. Similarly, little depth 1, 2, 3 and 4. Okay. So, this cylinder profile is generated, you can see here. So, we have plane 1, plane 2 and cylinder. Now, we can set the reference system here, reference system, that what should be the reference point for rest of the workpiece. So, I can keep the center of this cylinder as origin. For that, what I have to do, I select the reference system, select the primary axis here, the primary axis. Now, I will select for the after primary axis, I will select plane 1 or minus z direction it will be plane 1, plane 2 and cylinder. Plane 1, plane 2, okay, and next is cylinder, okay. Now, the center of the cylinder is my origin, you can see here, the center of the cylinder is my origin. So, this is my reference, the two planes and one cylinder center has made us to select the reference system. So, we have got the origin point here, that is the center point, origin point here, the center point of the cylinder is the origin. So, next is how to measure all the parameters. We can select the circles here, these 6 circles, okay, this is cone here as well. So, to measure the circle, we will select circle from here, then measurement parameters. So, it is trying to retract from the 2 mm, we have generated 1. So, at least 3 points are required to locate a circle. So, we retract at 1. So, this is 1, 2, 3. This circle is now located, because the origin we already have, this origin we already have here, okay, at this point we have the origin. The distance of this origin from here and this circle would be located by itself, okay. First circle, another we can, okay, this circle is generated here. So, I am not producing a cylinder here, I am just producing a circle. We can also produce it by taking 8 points in a similar fashion as we did for the previous cylinder or the center cylinder. Now, second circle, okay. So, let me try to show you the laboratory conditions, that what is the voice in the laboratory. I will just switch on my sound here, you can see 1, 2, 3, 4. We have marked 4 points, 3 points were the minimum, 4th point can also be marked. So, you can see in laboratory conditions there is a lot of noise, okay. That is why we have tried to record separately in the laboratory. So, you can see, you can just now watch that the blink of the indicator is also there and the beep is also there. 1, 2, 3, 4, 4 points are marked, okay. We can start it with, for the circle 4 points are better to choose. So, similarly, we are trying to make these circles, okay, 1, 2, 3 and 4. When that probe is touching the surface, these points are being marked here. So, these 6 circles are located here, okay. Now, again select the plane. So, it will measure the slant plane. Let us measure this slant plane here, okay, this slant plane here. Also, we will try to say 1, 2, 3, okay, 4. We can mark more than 3 points as well. So, this slant plane is also located here. So, what is the angle between the plane, between these two planes, this slant plane and this xy plane? So, we can go to construction. You can see we have measure here, measure, and we have construction here. In the construction, we can click angle. Now, it will ask between which entities you need the angle. Okay, plane 1 and plane 3. Okay. So, the angle between plane 1 and plane 3 is 45 degree. So, this is the angle it is showing, 45 degree angle. So, similar to the angle, we can also measure the distance between cylinder 1 and circle 1. Between this cylinder 1, this is a cylinder 1, this was cylinder 1 and circle 1. Okay. So, we will select the distance, we have selected distance here between cylinder 1 and circle 1. So, we have selected distance here, distance in place of angle, distance between cylinder 1 and circle 1. Okay. So, distance between cylinder 1, this is circle 1 and cylinder 1, that is the origin, is 11.98. Okay. It is showing the nominal and measured. Okay. The different planes here, this is xy plane, this is yz plane, this is xz plane, this is again yz plane. Okay. So, this is again xz plane. So, now rotate it 90 degree, A 90 degree, B 180. Okay. Let me repeat this. This is A 90, B 180. If I have made this change, I have to put this change in the software as well. So, I will put A 90, A movement as 90 and B as 180. So, I am putting this movement, reference to, if you see, this is A 90, B 180. Okay, you can see A 90 here, B 180. Okay, A 90, B 180. We click yes. Because we are going to measure now the YZ planes, that is why we have turned this to this direction. This is a locking nut on this side, locking screw on the other side. We have locked the probe here. Now, we will measure this YZ plane. Again laboratory. So, we will measure the 8 points here, 1, 2, 3, 4 in the laboratory conditions, 1, 2, 3, 4. Okay. So, we have located another cylinder here. Okay, which is at 90 degree to the cylinder 1. Cylinder 2, this is cylinder 2. Yes, this is 90 degree to cylinder 1. So, how much is the depth from the planes? So, we select the plane again. So, this is YZ plane. This is YZ plane 1, 2, and at any point you can just touch it, 3. Okay. This is YZ plane. So, we go to this construction, and try to see the distance from the plane. Well, let us see the angle of the plane with cylinder 2. Okay, we are taken it to some high position, and we will go to construction here. Then we will select the angle. Okay, this angle is selected. Angle between, you can see plane 1, enter, and cylinder 2 should be there. Cylinder 2, enter. Okay. Now, we click OK and yes. Now, between this cylinder and this plane, what is the angle? What should be the angle between this cylinder and this plane? Is there any angle? No, the angle should be 0. Let us see what is the angle. What does the computer reports. So, it is showing the angle as 0.173004, it is quite close to 0, 0.1. Okay. So, it is 0. Okay. So, this angle is 0. Using construction we can measure the angle, distance, then the depth, okay, the arc, all these things can be measured. Now, we will measure this cone here. Again we will change the position to measure this cone. A has to come back to its 0 position. You will select A0 and B0, okay, A0 and B0. So, we click OK, yes, okay. So, A is again brought to 0 position and B is again brought to 0 position. The angle is 0, 0. Lock the nut here. Okay. Now, we will measure the cone. So, it has appeared here. Now, we will mark the points. We will measure the cone 1, 2, 3, 4, then little depth in another plane, in the second plane. So, the 4 points in one plane, the 4 points in the other plane were marked. So, it has generated 4 plus 4, 8 points in 2 different planes. So, this is the measured and the nominal dimensions here. So, let us see, it is also giving the height of the cone from the reference plane. So, here is the cone. So, the cone angle here shown is, the cone angle is 45 degree. Okay, you can see the cone angle here, cone angle is 45 degree. So, then we go for A 90 and B 0. A would be 90, B is kept at 0 position only. Let me turn A to 90. Okay, A is turned to 90 degree and B is at 0 position only. So, let us measure the plane on the other side. This will be named as plane 5. So, this is YZ plane, YZ plane, that is Y axis and Z axis. So, we will select 3 points, we will check another plane here, YZ plane, we will check 3 points near to YZ plane circle. So, we are measuring this plane at an angle 1, 2, 3. Okay. So, we select the plane, take 3 points near to YZ plane circle. Okay, this is the plane at an angle, this is the plane at an angle. Okay. Now, this is the potential or the beauty of the CMM, that we can by using a single setup we can measure all the parameters in different directions, in different this is a structured, or this is a structure of the known parameters, cylinder, cone, all those things. Also free form can be measured. Okay. So, we can store the data files in IGS format. So, these all parameters can be exported, then we can save it to the file, all those things can happen. So, they are now measuring the circle on the other side on the YZ plane. So, we can save the data in Excel format. Okay. Now, this circle is again measured. This plane is now, this plane is again measured, the YZ plane, the YZ plane is measured. Okay. Now, we are measuring the circle on the YZ plane, there is circle on the other side like this, actually cylinder on the other side as well. Okay. But we are just measuring the circle. 1, 2, 3 and 4, So, you can see this circle is located, big circle on this plane. Okay, circle 7 on plane 6, this is plane 6, this is circle 7, this is located here. Similarly, we can locate all the features, but now I like to move forward. So, we will try to see how the data is stored. So, IGES format is there. Okay, IGS format, data can be stored in IGS format. We click that IGS. So, what data we like to store? What points? All the compensated points. Okay, then we export it into the IGES format. Okay, so it is located in desktop frame curve. IGS format is located there. So, we can read the IGS format. Also, the data can be generated in the Excel, and also we can have the PDF file. We are now making a PDF file. Okay, we just named it ABCD. Now, we will save it as PDF is already saved here. So, now I am opening the PDF file. So, this is the element list. We have generated this plane and the dimensions of the plane x, y and z, measure, nominal, what is deviation, okay. Then up, low, and you know these derivation, these distribution, not exactly distribution, but the tolerances can also be obtained from here. Then plane 1 we measured first, then we measured plane 2 dimension for that. For the cylinder we have x, y, z, diameter of the cylinder, cylindricity is close to 0, then sigma value for that. Then for circle also circularity is 0, 0, like it is perfect circle. So, x, y and z coordinates and diameter of the circle, it is 6 mm dia. So, it is showing like quite close to 6, this is 12 mm dia. So, this 11.999, it is quite close to the 12 mm. Then we circle the circle 2, okay, circle 3, circle 4, circle 5, all these circles, okay. The coordinates of the circles which, okay, the first circle or the cylinder that we have, similarly the circle 2, circle 3, circle 4, okay, circle 5, the dimension for that. So, then we have circle 6, plane 3, that was xy plane, the angles that we measured, the angle for the first angle that we measured between plane 1 and plane 3, plane 1 and plane 3, the angle was 45 degree, okay. Then distance we measured between the origin that is the cylinder and the circle, okay, that distance is given here. Then cylinder 2 features. So, these features are all stored here. This distance between plane 1 and cylinder 2, if you remember, this distance was 0.17, okay. So, this distance is shown here. So, all these features that we measured are also stored here, the data is stored. Not only this data, the coordinates, we can also generate the equations out of them. Also we can obtain the this same 3-dimensional feature, okay, this shape. Like I said, from this is point cloud I can generate, because this was a structured form. So, I just use the manual operation. I can also use the CNC operation. In CNC operation what we do, we actually just put the joystick away, we would not use the joystick, and just will command the machine that at each 1 mm or at each 2 mm it will locate the points. So, you can see I have just brought it close to the plane. So, nominal path, the auto measure the start point of the curve. So, this is automated mode. So, start mode is located, this is a start mode located. Now, the maximum step is 3 mm, this step is 3 mm. To locate a denser mesh or denser point cloud, we can reduce this length. Okay, let us reduce this to some shorter length, 1 mm. Okay, go first position. Okay, yes, move the tip to position, clear first point and scan. Okay, now at each 1 mm, when we click at each one, we start looking at the point. The first reference point, it has started from this point. We have kept joystick here, it is moving by itself. You can see at each 1 mm it is measuring. Okay, at each 1 mm it is recording the points here. You know, the points are being added here. It will keep recording unless it limits exceeds, like the, you know, in this direction, in the x direction 500 is the length it can move, 500 mm. So it can keep moving up to 500 at all, unless this workpiece finishes here, it wouldn't find anything here. Okay. So this is 1 mm. So let me try to do it again. So you know, at the end, now it has moved to the other direction, 90 degree. Okay, 90 degree is now again locating the points here. Okay, the people are talking in the laboratory. So it has generated only 13 points, and we shown here it has generated more than maybe I think 30 points. It has been, so these points are located at each 1 mm distance. You can see the points are generated. Okay, this is how the automation or the CNC mode of the machine works. So this is, we have generated the features. Now this is, we have generated the features. We have generated this was structured point cloud and triangular mesh. We can say we can generate of that. The next step was the alignment. Okay, the alignment of these shapes can be done to generate the overall this 3D shape. Okay. So it has generated the curve at a distance. We didn't actually define the home position before. It has generated a curve at a place at a distance from this surface that we generated. So let us try to do this again. So it has come here. We didn't change the A0 and B0. You know, A0 and B0 was to be kept. So maybe the start point we changed A to 0 and B to 0. A0, B0. We measure it again. Now let us keep the distance as 2 mm and measure it again. Okay, we have kept the joystick here and it is now measuring. Now the gap is 2 mm. So now the machine is working in the CNC mode. So this is how our software and this coordinate measuring machine works. You can see the points are being generated here. You can see the points are being generated here. Okay, 6 points are generated at 2 mm distance each, and auto measure again we can keep measuring like this. So this is how we use the coordinate measuring machine. This was just very trivial or very basic use of the coordinate measuring machine that we saw in the laboratory. We can also measure the curves, the unknown curves or the unstructured features. The similar procedure would follow. We will just first generate the points. Okay, using CNC mode we can generate the points. The point cloud can be generated. Then we can have the triangle mesh of that if we need to do some analysis. Triangle mesh is required when we need to produce the shape from the point cloud. Then we optimize the mesh, okay, what size of the triangles do we require, then we align them to get the final shape, and finally the data can be stored in the STL format for the production, for the manufacturer or for the engineers. So at this juncture, this was all in 3D measurements. So thank you for being with us. We'll meet you again next time. Thank you.